The Lost Inventions of Nikola Tesla. One of my greatest heroes of the scientific age is often a forgotten one. Nikola Tesla, 1856 to 1943, was an electrical inventor, and he thought outside the box. Tesla was famous at the turn of the century for inventing the alternating current system we use today as the universal power supplies for our homes and industry. But his later inventions, documented in some 30 U.S. patents between 1890 and 1921, have never been utilized as Tesla intended, despite their obvious potential for advancing in fundamental ways the technology of modern civilization. In fact, we are only now beginning to realize the depth of his genius. Among these lost inventions are the disc turbine rotary engine, the Tesla coil, electric energy magnifier, high-frequency lighting systems, the magnifying transmitter, wireless power, and the free energy receiver. Tesla was born in Yugoslavia, in 1856. He was educated at the Polytechnic School at Graz and at University of Prague. He worked as telephone engineer in Prague and Paris. He also conceived a new type of electric motor having no commutator, like a direct current motor has, but works on the principle of a rotating magnetic field produced by polyphase alternating currents. He constructed a prototype, but could find nobody interested in his invention in Europe. He emigrated to US in 1884, and worked briefly and unhappily with Thomas Edison. Tesla established his own lab and obtained patents on polyphase motors, dynamos, and transformers for a complete alternating current power system. He then formed an alliance with George Westinghouse, who bought polyphase patents for $1 million plus royalties. Together with Westinghouse, he engaged in a struggle against Edison to convince the public of the efficiency and safety of AC power over DC power, and succeeded in getting alternating current accepted as the electric power system worldwide. One of his most noted achievements that got acclaim far and wide while he was with Westinghouse was lighting the Chicago World's Fair. He also built the Niagara Falls hydropower plant, pioneering the use of moving water to generate electricity, and installed AC alternating current systems at Colorado in the silver mines, as well as other industries. By turn of the century he was lifted to celebrity status comparable to Edison's as the media promoted him along with the expanding electric power industry. Experimenting independently in his Manhattan lab, he developed and patented electric devices based on the superior capabilities of high-potential, high-frequency currents, the Tesla coil, radio, high-frequency lighting, X-rays, and electrotherapy. During this time he had a fire of a mysterious source that gutted his laboratory, and some believe it was arson. He rebuilt, however, and continued developing his inventions. He moved his lab to Colorado Springs for about a year in 1899. There, he built a huge magnifying transmitter. He experimented with wireless power, radio, and earth resonance. He also studied the principles surrounding lightning, and was able to artificially create it in the lab. He returned to New York in 1900 and with the encouragement of financier J.P. Morgan, promoted a world system of radio broadcasting utilizing magnifying transmitters. Tesla built a huge tower for his magnifying transmitter at Wardenclyffe, Long Island, and intended it as the first station in the world system he was advocating. He received enough funding from Morgan to bring the station within sight of completion. Then Morgan cut off the funding for no explanation, resulting in the project's collapse. Disillusioned, he continued to invent into the 1920s, but the flow of patents were meager compared to his earlier efforts, which amounted to some 700 patents worldwide. His high-frequency inventions were largely ignored by the established technology, as were his disc turbine, free energy receiver, and many other inventions. Shut out by media except for birthday press conferences, he used these conferences to predict future technology, such as microwaves, TV, beam technologies, the cosmic ray motor, interplanetary communications, and wave interference devices that since then have been named the Tesla howitzer and the Tesla shield. In the 1930s, He was involved in wireless power projects in Quebec. His last birthday media appearance took place in 1940. Tesla died privately and peacefully at age 87 in a New York hotel room from no apparent cause in particular other than perhaps old age and a broken heart. Personal papers, including copious lab notes, were mysteriously impounded by the U.S. government, but eventually surfaced many years later at the Tesla Museum, in Belgrade, Yugoslavia. Of these notes, only a fragment, the Colorado Springs Notes, has been published by the museum. Tesla's lost inventions. 1. Disk turbine rotary engine. Tesla called it a powerhouse in a hat. One version developed 110 hours. P. At 5,000 rpm and was less than 10 inches in diameter. Tesla believed larger turbines could achieve 1,000 horsepower. The disk turbine rotary engine runs vibration-free. It is cheap to manufacture because nothing but the rotor bearings needs to be fitted to close tolerances. It requires little maintenance. If necessary, the rotor can be replaced with ease. The turbine can run on steam, compressed air, gasoline, or oil. How it works. Unlike conventional turbines that use blades or buckets to catch the flow, Tesla's uses a set of rigid metal discs that, instead of battling the propelling stream at steep angles, runs with smooth efficiency in parallel with the flow. What drives the discs is a peculiar adhesion that exists between the surface of a body and any moving fluid. This adhesion is, in Tesla's words, caused by the shock of the fluid against the asperities of the solid substance, simple resistance, and from internal forces opposing molecular separation, a sticking phenomenon. The propellant enters the intake and is directed through a nozzle onto the discs at their perimeter. It travels over the spinning discs in a spiral fashion, exiting at the disc's central openings and is exhausted from the casing. Tesla notes in his patent that, in an engine driven by a fluid, changes in the velocity and direction of movement of the fluid should be as gradual as possible. This, he observes, is not the case, though, in existing engines where sudden changes, shocks, and vibrations are unavoidable. The use of pistons, paddles, vanes and blades, notes Tesla, necessarily introduces numerous defects and limitations and adds to the complication, cost of production, and maintenance of the machines. We who are stuck with the piston engine know this all too well. The Tesla turbine is vibration-free because the propelling fluid moves in natural paths or streamlines of least resistance, free from constraint and disturbance. Conducting the propellant through the intake valve on the other side easily reverses the turbine. Internal combustion. A hollow casting is bolted to the top of the turbine for the internal combustion mode. A glow plug or spark plug is then screwed into the top of this chamber for the ignition system. Sticking out of the sides are the intake valves. Interesting thing about these valves, there are no moving parts. They work on a fluidic principle. The Tesla turbine's only moving part is its rotor. Imagine a powerful internal combustion engine with only one moving part. Part of the valvular conduit patent, fluidics. The fluidic valve, which Tesla calls a valvular conduit, allows easy flow in one direction, but in the other the flow gets hung up in dead-end chambers, buckets, where it gets spun around 360 degrees. Thus forming eddies, or countercurrents that stop the flow as surely as if a mechanical valve were moved into the shut position. The spinning rotor creates plenty of suction to pull fuel and air into the combustion chamber. Tesla notes that after a short lapse of time the chamber becomes heated to such a degree that the ignition device may be shut off without disturbing the established regime. This is also known as dieseling. The disk turbine motor principle in reverse becomes a very efficient pump fluid drive. The disk turbine principle is employed in the speedometer, which presents the problem of having to turn the rotary motion of a vehicle's wheels to angular motion in order to push a spring-loaded indicator needle over a short arc. Tesla's solution: the speedometer cable connects to a disc which spins in interface with a second disc, imparting spin to the fluid in between and, hence, to the second disc which moves the needle. Interface two discs of different sizes in a fluid medium and any desired ratio between speeds of rotation may be obtained by proper selection of the diameters of the discs, observes Tesla in his patent. thus anticipating in 1911 the fluid drive automatic transmission. Tesla first worked on his turbine early in his career, believing it would be a good prime mover for his alternating current dynamos, far superior to the reciprocal steam engines that were the workhorses of that era. But he did not get down to perfecting and patenting it until after the collapse of his global broadcasting scheme. 1909. By this time the internal combustion piston engine was firmly rooted in Western power mechanics. Tesla referred to organized opposition to his attempts to introduce the superior engine, and so have others who have made the attempt since. But Tesla still saw a glorious future for his turbine. To his friend, Yale engineering professor Charles Scott, Tesla predicted, "My turbine will scrap all the heat engines in the world." Replied Scott, "That would make quite a pile of scrap." 2. Spark gap oscillator. Tesla was central in establishing the 60-cycle alternating current power system still in use today, yet he suspected that the more striking phenomena resided in the higher frequencies of electric vibration. To reach these heights, he first tried dynamos spun at higher speeds and having a greater number of poles than any that had existed before. One having as an armature a flat, radially grooved copper disc achieved 30,000 cycles, but Tesla wanted to go into the millions of cycles. It occurred to him that this vibratory capability was to be found in the capacitor. With a capacitor circuit, the spark gap oscillator, he did indeed achieve the higher frequencies, and he did so by non-mechanical means. The circuit was promising enough for him to patent it as a method of an apparatus for electrical conversion and distribution, for Tesla saw in it the possibility of a whole new system of electric lighting by means of high frequencies, though it was quickly succeeded by the Tesla coil and is not numbered among the more famous of the lost inventions. The spark gap oscillator is pivotal for Tesla as the invention that launched him into his career in high frequencies. How it works. The capacitor. There are only a few basic building blocks of electrical circuitry. The capacitor is one of them. Tesla didn't invent it. It had been around for some time, arguably for millennia, but he did improve upon it in 3 of his patents. Also called condenser, the common capacitor is just a sandwich of conductive and non-conductive layers that serves the purpose of storing electrical charge. The simplest capacitor has just 2 conductive sheets separated by a single sheet of insulation. In the capacitor shown, the conductive elements are 2 metal plates. The insulation between them is oil. In the official vocabulary, the plates are indeed called plates and the insulative layer, oil, glass, mica, or whatever, is called the dielectric. Connect the 2 terminals of a capacitor into a circuit where there is plus-minus electrical potential, and charge builds on the plates, positive on one, negative on the other. Let this charge build for a while, and then connect the 2 plates through some resistance, a coil, say, and the capacitor discharges very suddenly. Tesla said, "The explosion of dynamite is only the breath of a consumptive compared with its discharge." He went on to say that the capacitor is the means of producing the strongest current, the highest electrical pressure, the greatest commotion in the medium. The capacitor's discharge is not necessarily a single event. If it discharges into a suitable resistance, there is a rush of current outward, then back again, as if it were bouncing off the resistance, then out, and back and so forth until it peters out. The discharge is oscillatory, a vibration. The vibration can be sustained by recharging the capacitor at appropriate intervals. When Tesla talked about the capacitor's discharge causing commotion in the medium, he meant that a vibration or mix of vibrations were disrupting the ether. The character of this vibration is determined in part by the capacity of the capacitor, that is, how much charge it will hold. This is a function of its size, the distance between plates, and the composition of the dielectric. Upon discharge there would be, typically, a fundamental vibration, some harmonics, and perhaps other commotion, maybe musical, maybe not. Additional circuitry can tame the vibration to a pure tone. 3. The medium. When Tesla speaks of commotion in the medium, what is the medium? In Tesla's time it was an article of faith that there existed a unified field that permeated all being called the ether. The ether as the electric medium still is an article of faith in some circles, but in official science its existence is presumed to have been disproved in the laboratory. Nevertheless, this conviction about an ether ran very deep, not only among scientists but among all thinkers, until only about 40-some years ago when particle theory, E equals mc2, and, finally Hiroshima firmly established the new faith. Tesla said the electron did not exist. The materialistic concept of these little particles running through conductors is alien to Tesla electric theory. Here is the Quaker writer Rufus Jones on the ether in 1920, an intangible substance which we call ether, luminiferous, light-bearing, ether, fills all space, even the space occupied by visible objects. And this ether, which is capable of amazing vibrations, billions of times a second, is set vibrating at different velocities by different objects. These vibrations bombard the minute rods of the retina. It is responsible also for all the immensely varied phenomena of electricity, probably, too, of cohesion and gravitation. The dynamo and the other electrical mechanisms, which we have invented, do not make or create electricity. They merely let it come through, showing itself now as light, now as heat, now again as motive power. But always it was there before, unnoted, merely potential, and yet a vast surrounding ocean of energy there behind, ready to break into active operation when the medium was at hand for it. Jones, who was not a scientist but a religious thinker and communicator, was making a point about the nearness of God's power and could do so by invoking the physics of his time. This would be difficult using the Einsteinian physics in fashion today, which W. Gordon Allen has called atheistic science. Although the ether is intangible, it is assumed to have elastic properties, so that Tesla can say a circuit with a large capacity behaves as a slack spring, whereas one with a small capacity acts as a stiff spring vibrating more vigorously. This elastic character of the ether, which you experience palpably when you play with a pair of magnets, is due to the medium's lust for equilibrium, distorted by electrical charge, or by magnetism, or by the gravity of a material body. The ether seeks to restore a perfect balance between the polarities of positive-negative, plus, minus, yang, yin. Voltage is the measure of ether strain or imbalance, called potential difference, or just potential. Balance is not restored from this strained condition in one swing back. As we have seen with the capacitor, the disturbed electric medium, like a plucked guitar string, overswings the center line of equilibrium to one side, then to the other, again and again, and this we know as vibration. In this way of looking at nature, vibration is energy. Energy is vibration. So you could say that the commotion in the medium caused by the capacitor's discharge is energy itself. Thus, you can speak of the capacitor as an energy magnifier. Even though a feeble potential may charge it, the sudden blast of the capacitor's release plucks the medium mightily. The capacitor is common in modern circuitry, but Tesla used it with much greater emphasis on its capability as an energy magnifier and on a scale almost unheard of today. It's difficult to find commercial capacitors that meet Tesla specifications. Builders of Tesla coils and other high-voltage devices usually must construct their own capacitors. Fortunately, this can be done using readily available materials. How it works. The spark gap. A simple way to discharge a capacitor is through a spark gap. The spark gap oscillator is just a capacitor firing into a circuit load, lamps or whatever, through the spark gap. The opening between the spark gap electrodes determines when the capacitor will fire. This setting is one determinant of the frequency of the circuit. The others are capacity and the reactance, or bounce characteristics, of the load. The potential needed to bridge the gap is in the tens of thousands of volts. It takes a potential of about 20,000 volts to break down the resistance of just a quarter of an inch of air. The gap doesn't necessarily have to be air. Tesla has referred to a gap consisting of a film of insulation. A spark gap is a switching device, a semiconductor in fact. But the spark gap is problematic, particularly the common two-electrode air gap version. Heating and ionizing of the air cause irregularities in conduction and premature firing. This arcing must be quenched. It can be to a great degree by using a series of small gaps instead of one larger one, or by using a rotary gap. Tesla also immersed the gap in flowing oil, used an air blowout, and even found that a magnetic field helps to quench. For the gap, Tesla substituted high-speed rotary switches, which he called circuit controllers. One has a rotor that dips into a pool of mercury, and another uses mercury jets to make contact. You can operate a spark gap without a capacitor by connecting it directly to a source of sufficient voltage. This is, of course, how our automotive spark plugs work, directly off the coil. The capacitor in that circuit is used to juice the ignition coil primary. The auto distributor, incidentally, is a rotary gap. Pure Tesla. Early radio amateurs used spark gap oscillators as transmitters. The capacitor was, more often than not, left out of the circuit, but with it the transmitter could create a greater commotion in the medium. 4. Tesla coil. Tesla's best-known invention takes the spark gap oscillator and uses it to vibrate vigorously a coil consisting of few turns of heavy conductor. Inside of this primary coil sits another secondary coil with hundreds of turns of slender wire. In the Tesla coil there is no iron core as in the conventional step-up transformer, and this air core transformer differs radically in other ways. Recounting the birth of this invention, Tesla wrote, "Each time the condenser was discharged the current would quiver in the primary wire and induce corresponding oscillations in the secondary. Thus, a transformer or induction coil on new principles was evolved. Electrical effects of any desired character and of intensities undreamed of before are now easily producible by perfected apparatus of this kind." Elsewhere Tesla wrote, "There is practically no limit to the power of an oscillator. The conventional step-up transformer, short primary winding, long secondary on an iron core, boosts voltage at the expense of amperage. This is not true of Tesla's transformer. There is a real gain in power." Writing of the powerful coils he experimented with at his Colorado Springs lab, coils with outputs in excess of 12 million volts, Tesla wrote, "It was a revelation to myself to find out that a single powerful streamer breaking out from a well-insulated terminal may easily convey a current of several hundred amperes. The general impression is that the current in such a streamer is small." How it works. A Tesla coil secondary has its own particular electrical character determined in part by the length of that slender coiled wire. Like a guitar string of a particular length, it wants to vibrate at a particular frequency. The secondary is inductively plucked by the primary coil. The primary circuit consists of a pulsating high-voltage source, a generator or conventional step-up transformer, a capacitor, a spark gap, and the primary coil itself. This circuit must be designed so that it vibrates at a frequency compatible with the frequency at which the secondary wants to vibrate. The primary circuit's frequency is determined by the frequency and voltage of the source, the capacity of the capacitor, the setting of the spark gap, and the character of the primary coil, determined in part by the length of its winding. Now when all these primary circuit components are tuned to work in harmony with each other, and the circuit's resulting frequency is right for plucking the secondary in a compatible rhythmic manner, the secondary becomes at its terminal end maximally excited and develops huge electrical potentials, which if not put to work, boil off as a corona of bluish light or as sparks and streamers that jump to nearby conductors with crackling reports. Unlike the conventional iron core step-up transformer, whose core has the effect of damping vibrations, the secondary of the Tesla transformer is relatively free to swing unchecked. The pulsing from the primary coil has the effect of pushing a child in a swing. If it's done in a rhythmic manner at just the right moment at the end of a cycle, the swing will oscillate up to great heights. Similarly, with a right timing, the electrical vibration of the secondary can be made to swing up to tremendous amplitudes, voltages in the millions. This is the power of resonance. 5. Man-made earthquake. Tesla was fascinated with the power of resonance and experimented with it not only electrically but on the mechanical plane as well. In his Manhattan lab he built mechanical vibrators and tested their powers. One experiment got out of hand. Tesla attached a powerful little vibrator driven by compressed air to a steel pillar. Leaving it there, he went about his business. Meanwhile, down the street, a violent quaking built up, shaking down plaster, bursting plumbing, cracking windows, and breaking heavy machinery off its anchorage. Tesla's vibrator had found the resonant frequency of a deep sandy layer of subsoil beneath his building, setting up an earthquake. Soon Tesla's own building began to quake, and, just at the moment the police burst into the lab, Tesla was seen smashing the device with a sledgehammer, the only way he could promptly